All right, in this video, we're going to talk about terminating coaxial cable. Uh, the most common type of coaxial that you're going to encounter is going to be the kind that you have going to your home internet and television boxes. It's going to be RG6 cable with the F-type connectors. Now, if you look on the cable itself, cable is marked. This marking here tells you that this is 5-star brand coaxial cable, RG6 dual shield CM black. You also got some other manufacturer identifications here. And then down at the end, it'll actually tell you how many feet you have left on your spool or in your pull box. Sometimes things are spooled in reverse. So, you just need to pay attention to whether the numbers are going up or down. But that's more useful during project installations. Now, the three types of coaxial that you're going to come across are going to be RG59, RG6, and RG11. RG6 is the most common type, and this is what's more than likely in your home, going to your cable or television boxes. But in some places that still use the older RG59, the cable is just slightly smaller diameter, not enough to be able to visually tell the difference very easily. So it's very important to read the markings and look to see whether it's RG6 or RG59. The reason for that is because the terminations that you use have to match the type of cable you use, because the diameter on the inside of it is determined by the cable type. So this F-type compression connector is for RG6. If you try to use this on RG59, it's going to be too big. And here's just an example here. The one on the right is RG59. It's much smaller diameter. The one on the left is RG6, and it's a bit larger. So you have to match the connector type to the cable type. And this is how you definitively discern that, by reading whether or not it's RG6 or RG59 from the cable itself. RG11 is a lot larger in diameter, and it's typically used by the cable companies to accommodate a long distance cable length from a utility pole to a building, because the building is obviously very far, or farther than usual, from a utility tap access point. So typically the RG11 is going to be a service drop, but sometimes, if it's like a hotel or something, they may have long distances that they need to span, so it could also be used in that case. But RG11 has much better attenuation than RG6 and RG59, so you get more usable length out of the cable than you do RG6 and RG59. Some other things to pay attention to, just like with twisted pair wiring. It tells you that this is dual shield CM, RG6 dual shield. There's also RG6 quad shield, and that would be usually called RG6Q. But this CM tells you that this is CM cable, which means communications multi-purpose. This is not CMR or CMP. So you cannot use this to go between floors like you would use CMR. And you cannot use this up in a drop ceiling space or a plenum space. Basically a plenum is defined as having, a return air intake up inside of the ceiling. So for many folks, it can be ambiguous. We just limit it to, hey, if it's a drop ceiling, it needs to be CMP. But this is not rated for low smoke, or fire resistance. This is just general multi-purpose cable. That's what CM means. These same designations are used on your twisted pair cabling. These are all important things to take note of when we're installing this, because it may pertain to industry standards and electrical code. Now, to get into the deep part of this, I'm just going to take these snips and cut this old termination off. And then we're going to take our stripper tool here and strip this cable down so that we can talk about its inner components. But pushing down here, you can see that inside of this stripper tool, there's actually two separate razor blades, and they're different lengths. So one cuts deeper than the other. And if you look at the top here at this diagram, you can see why. It separates the copper conductor from the center shielding and dielectric. And so this needs to be inserted on the wire in the proper direction. You can see all the way in the back of this is the longest razor blade. So it's going to be facing towards my termination. And I'm just going to slide this in here. And I'm going to let it drop. Give me a little more closer to the edge there. And after depressing this and then letting go of it, it's now grabbed this cable and it's pushing the razor blades against the PVC. And so what I'm going to do is hold the cable firmly and use this loop here to just spin this clockwise about 1.5 turns and then 1 turn counterclockwise. I'm going to push it down again and then I'm going to slide this off. Now what this stripper tool has done is actually cut this cable in 2 separate places. It's kind of hard to see right now, but as I grab this section and twist it and pull it away, I can see the copper conductor in the center exposed. The second cut is a more superficial cut. So all I have to do is twist this PVC, start to pull it away, and you can see how it only cut the PVC and it left the shielding and the dielectric intact. So as I pull this off, we're left with this. And so on this wire, you have your center copper conductor, you have braided shielding, which I'm just going to use the tip of my finger to pull back. That's part of this termination process. Just peel it back all the way around the wire. And what you're seeing there is the braiding pulled back, the foam dielectric in the center covered with an aluminum shield, and then your copper conductor. Get this a little bit closer here. So your copper conductor is coming out of a foam in the center that's known as the dielectric. That foam is covered with an aluminum foil. It's part of the shielding. And then you have your braided shielding that we have now peeled back. This is the beginning of terminating this cable. Now this is an F-type connector. This F-type connector is a compression connector. So that means that this metal piece here is going to slide all the way up this plastic to here and actually grab this wire and secure this termination into place when this termination is compressed by the tool. This is the most common type you're going to see for cable applications, such as TV and internet. It's called an F-type connector. And this is a type of connector that you're going to see often in like analog cameras or, some other applications, maybe even industrial environments. But this is called a BNC connector, and it's the push and twist lock type connector. But just remember, this connector I have in my hand is RG59. It's too small to fit over this wire. So if I was going to use a BNC, I would need an RG6 type BNC. This F-type connector is RG6, and so it will slide over this just fine. And what we're looking for is this, you see this center aluminum tube? This dielectric is going to slide inside of that. And the metal surrounding that tube is going to slide in between the dielectric and the braiding. So as I put this on, I'll have to line it up, twist it a little bit, and it'll start going in there. And then you'll meet the point where that central tube is starting to get in between the wire braided shielding and the dielectric. So what I usually do is, grip the cable firmly on one side and then grip the termination firmly, and I twist and push the two together. What we want is for the foam dielectric to be flush with the inside of that termination. We don't want it to go so far that it sticks out of it, such as this. We don't want that, but we want it to be flush. Okay. Next thing we're going to look at is the length of this copper conductor. It needs to be at most about the width of a nickel. But here's the way I've always done it, because the bevel on the cutters is just the right size. So I take this beveled edge and I put these cutters right up against the face of this termination, and then I snip it off. Perfect length. Okay. Reason being is when we plug something that's got too long of a conductor into the female connector, it will damage that connector. So it's very important that our copper be of the proper length. And all it takes is just hitting the face of it with your wire cutters or your dikes. And now this is ready to use the compression connector on. This compression connector has a plunger here that this centerpiece goes inside of, like so. I'm going to take that back out of here so you can see. Each tool is going to be just a little bit different, but it's roughly the same principle. So your coaxial cable is meant to go inside, like the copper conductor goes inside of the hole in that plunger. So I push it down so I can line it up, and I push that all the way in there. And then what you'll see is these little blocks locking behind it. Okay. This is what, when we depress this plunger, it's going to push up against these to compress this connector. There's also different ones, because you may have different size terminations, and it will just give you, another different length to compress against. This plunger is also adjustable in multiple places, so you can actually use your specific termination, and you should, basically calibrate your tool to make sure that you're compressing it properly and not damaging it. So you can adjust the overall length of the plunger. Make it longer or shorter by using this flathead looking screwdriver shape on the front of it to turn this whole plunger, to turn this entire plunger and make it move backwards or forward, and then you lock it in place with this spinning piece here. And then you can also adjust the inside depth by rotating this piece here. But cutting to the chase, this goes inside of there. It backs up against this stop here. And then all you do is compress it, and that plunger will compress that connector. It's now shortened. And just release it. And now I have my new terminated coaxial. The process is exactly the same for one of these BNCs. Pull the braiding back, slide it over, put it in your compression tool, and compress it down. It's just a different type of connector. And again, these are different sizes, as you can see. The compressed size is going to be a little longer than the compressed size of the RG6. So you may have to adjust your tool to accommodate that. Or it may just be that you just need the second set of stops rather than the first. Just adjust your tool accordingly to make sure you get a good termination. They do make cable, coaxial cable testing tools to test continuity. Uh, they're just the same as your tools that you use for UTP. It's just you have to buy a tool specifically for testing coaxial to know whether you have, a good solid copper all the way through. No breaks in the conductor. That's what continuity